Holy shit. We got 32 fucking people watching already, man. Holy shit. Yes. Where's my live? Are we live right now? Holy shit, we're already fucking live. I didn't mean to go, I didn't know that it was clicking live already. I thought I was just in the prep mode getting the audience ready. Alright, so I removed those last videos. I'll put those back up, I think. There was some negative stuff at the end, and I also feel kind of bad. Like, I was talking about using scientists and suppression of science and talking about stuff like that at the end. I was getting a little crazy at the end. So I said some stupid shit about Eugene Malov, and I wanted to get rid of that, and I get the facts wrong about like that, but I should post the video back up. But the main reason I took it down is because of the shooting that I showed that had happened at this place. I don't want to like get involved in it. I don't want it to be out there on the internet. I have the full video, but I don't want to even post it anywhere. Don't want nothing to do with it. Some crazy stuff happened here. My family moved out. I've been out of commission for the past like week because I've been moving. It takes a lot to pack up all your stuff and move somewhere, but we're still local to the southeastern Mass. I'm trying to get everything set up over here at my apartment that I still have. This apartment, I'm basically turning it in. This is gonna be my last podcast with this setup and this stupid backdrop, okay? Because very soon I'm gonna switch to I'm gonna get a high definition camera, and I got a whole set that I'm building out there, where I'm gonna have a real professional podcast set up with lapel mics and a sound system. I got a board. I wish I could show you show you everything I have. I need to get it set up, but I want to get someone in studio to kind of help me run podcasts, and we're getting this set up. I'm basically getting it set up so that I can do this a lot more. I can get a lot more video content done, get a lot more interviews done. I got a 4K camera now, so I'm going to go around and do interviews. Try and get more people to give interviews and do interviews, and I got to get more things associated with that. I'm also in the process of a much needed update, and it's a lot of work though, because there's so much information. It just more pours out and comes out more and more every day. We're going to get a whole bunch of information going on Hover Brothers. I'm getting that database project together. I've gotten so many dumps from so many people just sharing stuff into this folder, and so many people uploading and bringing this together. This database project is disclosure. This is the best thing that I felt anyone could do for disclosure, and I'm glad that I'm doing it and part of it. We're also combating all the disinformation and the liars out there and stuff. So I'm also putting together my a documentary. I don't know if I want to talk about it. I'm still going to do it. I'm going to do it. I have to do the documentary on Lazar and expose all the times he's lied, and all the things he says. Nothing dangerous about it. Talking about lithium hydride. When I have the material safety data sheet, right here, accident, it's very, very dangerous. It is a level 3 health hazard, a level 3 fire hazard, and a level 2 instability hazard. For people that want to look that up, but I'm putting the documentary together on that, getting more scripted content, and that's my goal, is to put together more pre-scripted and edited down content, because there's a lot of stuff that we've figured out and are putting together with the research that's been done. And I want to do an updated video on anti-gravity, and I also want to do kind of more interviews and more like constant updates with the good groups out there, not the front groups, not the ones that you're going to see in the New York Times or being promoted out there in the mainstream, but the people working behind the scenes, like gravity's no warp dynamics, space warp dynamics. David, we were talking about David Perez earlier, and I was actually on the phone with, I was on Skype with Jeremiah, who should be calling back any time here, and I got some other people. Anyone want to call on Skype and get in on live on the show? I'm not one of those people. I'll answer. We'll get people on if people want to talk and have information to share, or get have something to add to kind of the conversation and the discussion. Let's bring it. We're basically what I'm trying to set up. I'm going to refocus on Hover Brothers, kind of Falcon Space, kind of. Still working with all these other groups of people and researchers. We kind of Falcon Space kind of has gone in its own direction, and but I want to cover them and still, Mark, he's still my friend. He's still a former colleague, and I want to promote what everyone's doing out there. At the same time, so he posted a video recently on their work, or on their YouTube channel, which you can go check out on Falcon Space YouTube channel. So I'm trying to link people to all these other space groups that are working on gravity research independently, like David Perez's group, Warp Drive Dynamics, which is now called Quantum Electrodynamics. The Quantized Inertia and M-Drive, the UK group with Quantized Inertia. And Jeremiah is joining us. He's a member of ARPE, which is the Association of Reactionless Propulsion Engineers, and he's our lead technician for that group. It's kind of we're all kind of it's a group.
It's a joint effort. There's no doubt about that.
It's definitely
everybody has their own unique role to play. Some people are purely informational in that group, and they don't do any experiments at all. But they help fuel the information needed to do the experiments, and they're critical and pivotal. Some people only do experiments, and they can't derive any of the information. They can't really understand the mathematics or read theories. But nevertheless, we have people to help them understand that stuff and break it down. So as a team effort, there's a lot of translation between these technical documents, things that need to be broken down and put into more common terms so that they can actually be conducted. And we have people that are excellent at actually conducting the experiments, that have the mechanical skills and the machining abilities.
Right.
So it works out really well.
I like our group. This is why I like this group. I'm a member of it. I've been mostly one of those members contributing, theory, because I'm basically throwing all these other theories from these other groups and other stuff that we can go and test in the lab and make sure it's legit. Because and if it works or not, and if we're not interested really. I mean, I'm interested 17% weight reduction, as was recently reported by Mark and Falcon Space. But with something like that, it's easy to for skeptics to dismiss it and say, "Oh, you're just measuring, scattering EMF and or RF." Or whatever they say, that there's any numerous device, mismeasurements and this and that. And we're really concerned. Same thing with cold fusion and my research in LENR and cold fusion. It's like, if you're not being able to create a power plant and really create a lot of usable energy, if I can't boil, that was the big argument that was put toward cold fusion years ago. And it says, if I can't boil a cup of coffee, right, just boil a pot of water for me, make steam. All you need to do is make steam with cold fusion, and if you can just make steam, then you're good, right? And then what we're talking about with anti-gravity is all we need is 100% weight loss reduction, over 100% weight loss reduction, because we need to be able to not just lift the weight of the machine itself. It needs to lift the weight. It needs to lift other stuff, too. So I think this is kind of the goal here, and I really enjoy being part of that group that we've started with the WhatsApp group and reading the ongoing discussions that take place there. Lots of insights, lots of good information, and lots of really good researchers and experimenters and engineers building a lot of cool stuff. And I think this is disclosure. It's disclosure through discovery. It's the fact that we don't trust mainstream narratives. I don't trust anything that comes out of the mainstream, anything that's like published out there. I assume that everyone's a liar, everyone's a fraud or misled, or even if they're not lying, that they're just genuinely misled themselves.
Yeah, I'm finding that to be the most common thing. Is that, I mean, from the people that I've talked to, they're very genuine. They really do believe what they're selling.
Right.
But a lot of times they are misunderstanding what it is that they're talking about. And I come from a calibration background, so a lot of the guys that are actually out there making claims about having successful devices, those are, of course, the easiest ones to look at and also some of the easiest to criticize because many times they're unorthodox.
Right.
And it goes hand in hand. If you don't have a classical training or background, if you didn't go to college or you maybe did but just didn't really take to that environment very well, you might have an unorthodox approach, and perhaps that is your key point of brilliance, but also it means that you're going to have issues translating that to the scientific community and getting it validated.
Right.
And one final example of that is I was talking to a fellow the other day. I won't mention which organization yet because we're still in conversation. But so the way that they're making their measurements,
and there's some. I just also want to quickly point out that there's other organizations that we haven't included because they don't want to be made public yet, but they still share some information with us and are in contact when the breakthrough does come. We will be able part of the in the loop for the disclosure network. But also I want to ask anyone in the audience if they I'm getting rid of some of these, and I'm still building this out. So anyone that wants to point out any groups that we should look into and include on this list, please include them below. And we're just trying to gather information and crunch it all. That's the goal. And keep going.
We can probably. Well, anyways, one of the things I had an issue with is they have their test sample they're trying to measure the thrust from. They power it up, and the way that the test sample is suspended, it's hanging from a series of springs. And so the weight of the sample is somewhat helped, and it has, a big power cable going to it, which is why they're using springs to support the weight of that sample. But when they turn it on, of course, they're getting some kind of lift, and they're measuring the amount of force they're generating in the amount of physical motion that the thing lifts up against the tension of the springs. So they calibrate the springs with a set weight, and they've been using this same 100 gram weight to just set on top of the sample and see how much the springs deflect. But obviously, springs are not linear. The more you stretch them, they're going to deflect.
I'm trying to get a visual up for this, so I have the wrong visual on the screen.
Okay, well, just imagine this. Imagine that you have a spring that's kind of hanging. It's a spring that you can stretch out, and it wants to pull back to being fully compressed, just like a slinky, for example. If you stretch out that spring by attaching one side to the ceiling and attaching a weight to the other side, depending on the weight and the tension of the spring, that spring is going to be slightly stretched out and uncompressed. So that's going to be stored energy that the weight is pulling down on the spring. Now, if you grab onto that weight on the bottom and you pull it down a little bit farther than what it's hanging and you release it, it'll bounce back and forth, oscillating, just like you're holding the end of a slinky, right? So that's the way they have their samples suspended, is from these springs. The springs are slightly stretched out. They're not completely stretched out, but if you take a spring and you stretch it more and more, as you begin to stretch to a certain point, the amount of force that it pulls back on is not linear. And it's not logarithmic either. It's to do with the malleability of the metals and the point at which they stop responding to return equal force because they don't have a perfect hysteresis curve.
It's not just negative kx. There's a bulk modulus.
Exactly. So using a spring as a counterpoise mechanism to make measurements is a very bad idea in scientific and calibration terms. It just doesn't yield a reliable result that's relatable. And just measuring the distance that the spring is stretched, there's no data to say at 100 grams the spring was stretched 1 millimeter, and at 3 pounds the spring was stretched 4 millimeters, because they're basically measuring in tiny millimeters of deflection. So there's no data to say this is how much it was stretched based on this amount of load weight that we put on it for calibration. And that seriously concerns me. But again, it's like the background of the guys who are doing it. They don't necessarily understand that stuff, so they haven't included it in their test setup, and they're certainly not likely to now change it after they've been doing it the same way for so many years, now over 7 years. And that's part of the problem, too, with some of this research, is that once people get set in a way and they have their way of doing things, John Hutchison is a fine example of this. Brilliant guy, extremely eccentric, got even more eccentric over the years. Now he's doing some really strange personal stuff.
Oh, Carla Nipton.
John Hutchison, you know that guy?
Oh, you mean Carla Nipton?
Oh, Carla Nipton, is that what she's calling herself now?
That's what she's calling herself now. But
I'm not sure if it was like the full thing or not. I mean, I'm not sure if John was just playing around with the concept or what exactly it was. Like, I don't have any problem with it.
I don't really know. I don't know. It's fun. It's just funny. I think he does it for attention, honestly. It's entertainment. I laugh because it's so funny.
And I don't have, if she's dead serious about it, right? I don't have any problem with that at all. I just think that it's so interesting to see, because this was a guy living in an apartment that loaded that thing probably to the weight-bearing limit with old radio equipment and was just screwing around with the electric field to the great detriment and annoyance of his neighbors and the local police and the building owners. So anyways, I mean, this guy was just playing around with stuff, and he was totally unconventional. So he discovered something that was really unique, and there's a lot of debate on whether or not Hutchison actually did do some of the things that showed up on video. And it's my very solid belief that he absolutely did. And one of the reasons why I think that the metal samples that we see, which are virtually disintegrated in certain areas, and some of the other strange anomalies that are videotaped there, the reason why I believe them is because I've also reproduced some of those things using different methods, and I've seen the same kind of effects. So that being said, it's not too hard to think that if he uses a combination of various fields, that it may in fact do what he's claiming it could do. And I understand why it'd be so complicated to reproduce.
You're right. Oh, I don't even have myself on the screen. I gotta go and fix this on the chat. No, what's it? People couldn't see on the screen. They couldn't see what I'm even looking at. Oh, that sucks. Anyways, go ahead, keep going. I gotta have someone who's good at on media to like help me run. I need a Jamie for my Joe Rogan. That's basically what I need. You know what I mean? I need to find someone who's wicked good on. I don't have any beers in the fridge. I gotta go. I meant to go before the podcast, but I didn't realize it was already starting and going live. And I came back and I was like, oh my God, we're live, and I just have to go.
I think people would understand if you just took a minute to run to your fridge and grab the beer, Jimmy.
I don't have any beer. I'd have to run to the store down the street, and that's a whole.
Oh, that's not going to work out very well. You better get somebody to get it for you.
Yeah, Carla Niption. I don't know. That's that's funny. I was showing that. Yeah, there's a whole bunch of videos of him on YouTube you can go check out if you really want to. But it is John Hutchison. Again, I have the whole Hutchison file too in the data dump, and a whole bunch of stuff on him from Tim Ventura as well. Tim Ventura just sent me a data dump as well. I'll be uploading that today. I want to get Tim Ventura on the show. I got to get Jason Verbelli. I've been requested to have him on to go talk to him. Of Searle Dynamics. So we got a bunch of people I want to interview and talk about. I just want to get the whole gamut of everyone out there and everything they're doing, and try to get, because there's a lot of people that have a lot of converging interests, and I want to get them all on my page. The same, they don't have to be on the same page, with all their theories and all their ideas, but I'm going to put them all on the same page with my page, because my goal is to keep track of all this, to watch it and to guide it and weed out the weeds. Once we've, when we identify the weeds, we weed them out.
Yeah, let me know when you're going to have Jason on the show if he ever does agree to that, because that is a person that I would also like to ask a few questions.
Yes. Shit, maybe we'll. We were talking. I'm gonna have to get back a hold of Jason and see.
Let's see.
And
here.
I also gotta get on Steve Cambian's show, but I gotta get my whole thing set up. I'm in the middle of doing that. I got my whole studio moved down to the basement in the new house, and I got internet all set up in there, so we can do live streams with the band and stuff right from there.
Yeah, that's awesome. So
cool.
If you want to see an experiment real quick, I'll just show you what I showed you earlier, Jeremy, which is this little electric field gravity simulator. So I've just got the power supply set to 10 volts here. And
let's get this on large.
Yeah.
Come on. Large screen.
Let's see when I see me on screen on my laptop.
This is what people want. This is what they came to see, right, folks? What's up,
I'm sure
guys?
they did. Well, it's something fun to play with, that's for sure.
Damn straight. This stuff is fun to play with, gravity and experiments. But one of the things I've noticed in all these experiments, right, all the reports of these anomalous experiments, they're always in microcavities with shells. They always have that in common, that it's like like a microcavity with and some kind of layered materials.
Like here, for example, we have a piece of glass. And this is about 2.5 millimeters thick, and I just have it set on a piece of wood here. This is a piece of ribbon cable, and I've taken every third conductor and pulled it back, so I have sort of this this two-phase 180 degrees grid array where each of these conductors is oppositely polarized except for the one between them, which is grounded. And so that creates these tiny little U-shaped electric fields that travel on the surface. And if I just hit that for a second, you're going to see some purple corona. So what I'm going to do now is just set this grid that has a visible dielectric barrier discharge down onto this piece of glass. And as you can see, as soon as I release power, I can release it, but I can pick this whole piece of glass up, and it's not that light. Now, if I turn the power way down, and I use some lighter weight dielectrics, and we'll just put two of these things up here. So these are just little pieces of plastic that I've sort of drawn shapes on with a marker so they're easier to spot. And I'll turn the power way down here, and this will adjust the frequency and also bring it up slightly. So you can see I can pick those up. And if I release the power, then they'll just drop right off. So there's no DC electrostatic field going on here. This is an AC current that's traveling through here, an AC voltage that's creating a magnetic loop, so there is some capacitance and some current. This is mainly a dielectric field voltage effect that creates a simulated gravitation on the surface of these pieces of material. And it's a nice, interesting little demonstration to show how there's one possible way, other than magnetic fields, to universally attract any material. And I have tested this on metals. I have a small brass pendulum I was able to pull towards that array, and I've tested it on a steel, I've tested it on aluminum foil. Now, as you've just seen, glass, plastic, and even wood and fiberglass. So it does seem to attract just about everything I've stuck close to it, and it's a near field effect. So the distance between my electric field lines, in this case, it's about 1.5 millimeters. And that means that the effective range I have from the surface is also about 1.5 millimeters. That kind of gives you the summary. Well, yeah, so that's how you can do a gravity simulation with a electric field. One of the many experiments that we're working on right now.
So one of the things I liked, I'm going to get a place for quotes, too, I want to put up on the page, because there's so many good quotes from so many of these scientists that I found put together. One of the ones I like is that, the critics said, you can't push off of nothing. How can you create a propulsion thing that pushes off of nothing,
But
we have to
use
liquid-fueled rockets. The only way is liquid-fueled rockets. And the response was to that was, no, you're not pushing off of nothing. You're pushing off of information horizons. Rindler horizons.
There we go.
So a Rindler horizon is basically created anytime you have these super fast charging and discharging of these capacitors. It has to happen really, really fast. But you basically carry this Unruh effect, and you're basically warping the Unruh radiation to create. You're creating like the flow of information basically around your craft. And this is the warp drive dynamics, man. This is the stuff that's going to build the stars and take us off this planet. And I just love how close we are and how awesome it is to be alive in this time, learning about all this stuff and watch it all take place, man. It's really freaking fascinating.
Oh yeah, absolutely. To Mr. DB Cooper 77 in the comments, yeah, if you make it big enough, a person would stick to it. you can feel the attraction on your fingers when you get it close to the grid. It's a very weak force compared to the total mass. So it's a contact area thing. It has to do with the total surface area in immediate contact or close to the area of the electric fields. Now, if you spread those fields out, I'm only using a few thousand volts on that array. And so the field is fairly weak, and it's also fairly close proximity. If you take those same parallel line conductors and you spread them out several feet, and instead of using a few thousand volts, you use a few megavolts, your effective field attraction area goes from being 1.5 millimeters, like it is in this test apparatus we just seen, up to the distance between the two electric field poles, plus the radio wave distance that it takes for those fields to travel, depending on their frequency. So if they're very fast, you get a much better coupling. But yeah, you could go out to several feet and attract a whole person and simulate the entirety of gravity if you had enough of a potential at a high enough frequency with a large enough separation between the electric fields. If that makes any sense. I hope it did.
So I got a lot of work to do still on this website too, man. That does make sense. We just got to we're keeping on testing and keeping on learning, man. I think we're close. We just have to figure out the material science to be able to build some of the things we need to do. But first, we need to get something, a lab set up where we can get and a media center set up. That's kind of what I'm trying to put together to cover all this stuff and put it all in one place and gather all the information that and put it all in one spot so that we can. So that it's easily navigatable and searchable, man. And I need so much help with this, dude. It's just I kind of have my own vision of how it all I want it all to be done and organized, but it's hard to get it to come into fruition of what I imagine it should be. But we're getting there, man. These are baby
It's a lot
steps.
of work. There's
These
no
are
doubt
baby
about
steps.
that.
This is going to be the next work for the next 10, 20 years, I feel. I thought we were going to crack this, 10 years ago, and I was wrong about on my timeline scale, and I realized that's a lot to do with the material science and stuff, which there's other people that we need to reach out to. That's why I want it to be an international collaborative team effort. We have so many groups that are working towards the same goal. It's important for us to try to set something up that's international. Yeah, I got to get an update from Ken. I meant to call him. I was just getting on the phone with Jeremiah, and I was like, dude, we should do a live stream and talk about some current events and talk about all this stuff, because we were getting into all this conversation just among ourselves, and I was closing windows, trying to clear
He's
out
like,
my
might
browser.
as well share it, right?
I might as well share it while I'm closing all these browsers and sharing these things. And this is the one I was going to close right when we had the conversation, and I was like, let's just go live. You know what I mean? So I was in the process of taking today to call everyone back and get a hold of people, and I do get a hold of Ken, because Ken's setting up a group too, and I want to put his group on here. Ken is the original Hover brother, and I want to put him on there as well, and and get advertising for his group. And we're already hooking him up with some really good people, and things. There's more going on behind the scenes with all this, because we're going to need. The whole idea is quantum non-locality. There's a time problem in quantum physics, and quantum physics says that things can travel faster than the speed of light with EPR quantum entanglement. And it's all about information exchanges. That was what the whole page on Hover Brothers, the theory page. I got to update some of this stuff too, but I got to organize it and really do a number on it, because I've been going through all this. I've been doing so much research on this. This is kind of just like stuff that I knew was valuable, and I wanted to throw it all together in one place and then sort through it later. Kind of like what we're doing with the database. And this is disclosure. This is how it's going to happen. There's going to be more information than people know what to do with right away, and it's going to take us 10 to 20 years to learn it all, and then teach the rest of everyone out there all about this stuff, because it's going to change and revolutionize everything we know about science and technology and the electromagnetic field and gravity and all the physics, the atom, what atoms are, how atoms interact with light, how it's all
Very
connected,
much so.
how it's all connected.
The one thing I've seen that I would say stands above and beyond almost everything else I'm looking at in these various categories of research is the idea that many, I would even say most of our theories have a foundation of simplified terms or simplified dynamics that don't include everything required. So just for example, Maxwell stuff, as I've mentioned before, Maxwell makes the assumption that a static electric field with a given vector potential has equivalent properties to a dynamic electric field with the same vector potential, even though one field has an associated motion because it's produced by the motion of charged particles, and the other field is produced by the static geometry and location of charged particles which are not moving. And so all of Maxwell's equations only compute for this one single electric field that exists. And in fact, there are two different electric fields that have different properties entirely, and the properties of the motional electric field depend on the velocity of the charged particles and the quantity thereof that are moving. And so there are other things that we need to look at and undo. And if you take into account just what I've mentioned right now and go back through physics and see how many areas this simple fundamental change in our understanding affects, it's very wide ranging, and there are a lot of things we'd have to correct.
All right, so some updates on some cool things. This was actually from 2017, and it was talking about a new type of material that they made, and it's not like any material that's ever existed, and it's metallic hydrogen, which is cool because Ed Fouché used to always talk about hydrogen crystals. He said hydrogen crystals. They were working on hydrogen crystals out, like. There's a lot of research going on into this, and now we found out, oh, they did it at Harvard, and it's coming out to the public. But I believe this is related to tech that we could have got from something else. You know what I mean? If this was ever alien tech, the stuff that I've been on the hunt for and really searching for that, that smoking gun proof of some kind of metal study from the, where did it go, which contractors and all that, It went to Wright-Patterson in Ohio, and I've been after this whole thing for years, as a whole bunch of other researchers have, and I don't think it's ever going to die, whether it's true or not.
I hear you.
Whether it's true or not, it's a merging of their technology with ours, and maybe I don't know. It's kind of like this backward seed that was planted.
That's one way to look at it. I hear you, man. We have to constantly fight our past, one way or the other, whether it's conventional theories and what we've learned in textbooks, or whether it's even fringe ideas or esoteric concepts. We always have to fight our past.
I've learned that, man. There's so much that goes on with conspiracies, and they just call it conspiracy theory. And no, I really think there's so much more that we're learning. But the metallic hydrogen stuff was really cool. A lot of cool elements. So what is the hafnium stuff? I don't even want to get into all that. But very interesting element if people want to look up some stuff. Yeah. Let's see what else was going on. NASA news. This is thunderstorm reach to continue electric properties of thunderstorms. Right. This is that
stuff is extremely important.
This stuff's important because you were talking to David Perez and of the guy who's trying to build those spaceships. He's got over 100% now claimed.
Right.
He
says that he found this stuff out by studying thunderstorms. So
that's
by
awesome.
Studying the electric properties of thunderstorms. So something very, very important.
Yeah, I'll post this. I should post this stuff, the links to this stuff in the chat. All right, so back to the ET thing. This was right there. We're going to close this out. We're going to talk about this real quick, about all the stuff that's coming. Speaking of stuff that's coming out, this was really dark. You know how Sacha Baron Cohen creates these alter egos? He dresses up and pretends to be these people and then gets these people to give all these crazy interviews and stuff. Well, apparently he pretended to be a billionaire and wanted to see how much stuff that he could get away with, you know, being a billionaire at a hotel, right
I should
here.
probably check into this thing because it sounds pretty interesting.
He said we were shooting some of this at the time of Harvey Weinstein, and he said we wanted to investigate how does someone like Harvey Weinstein get away with doing all this criminal stuff essentially, because he's just a billionaire, you know, and the whole network that surrounds these billionaires, you know, that allow them to get away with, you know. So it gets worse. So he told the concierge right at the hotel that he needed some help silencing an 8-year-old boy that he just molested. And this is extreme comedy, and we thought that
Holy shit.
they thought the guy would leave the room and just be like, you know, like totally turned off. But instead, the concierge stays on and listen. You got to go help me get rid of the problem. And this guy starts advising him on how to get rid of the whole issue, and even at one point talking about murdering the boy. And
holy, I gotta see this now.
Yeah, this is pretty
nuts. Is there a video for this?
I hope so.
Oh man, this sounds like insane.
Yeah. I don't know if it's real or not, man, but you know, it just kind of like makes you really think, like, dude, yeah, these people have so much money. It's just like all they gotta do is pay, you know, pay everyone 10 grand, and I'd shut up, you know. Give me 10 grand right now. I'll shut my mouth about, you know. You don't want me to talk about this. You give me money to and tell me what I can talk about that is of my interest, and give me some money, please.
If I'm going to agree to not talk about something, that better be replacing that with something better.
Yeah, for real. I mean, come on.
I'll agree to not talk about something in a heartbeat under the conditions that what it is I was incorrect about, because I don't want to be talking about something that I'm wrong about, obviously, but that's just on fundament anyways. I'd do that for free, but I'll take somebody's money for it.
Well, if it's something, I don't know, that's like gets a whole nother level about what people would do for money, and everyone has a price and this and that, those kind of discussions. But anyways, yeah, I've just been reading up stupid stuff. I don't want to talk about that. Bosons and condensation of polaritons, of course. There's so much stuff on Wikipedia, and going on Wikipedia has been a great resource. You just click on, you know, like link people to, like, I was researching the the lithium hydride stuff we had talked about, the Bob Lazar. I already covered that. A force from nothing used to control and manipulate objects. Yes, this is this already got me like 200 likes in the quantum physics news group. People love this stuff, and it's again microcavities with layered micromaterials, not nanomaterials. You don't need to get that small, just micromaterials will work. And the layered cavities make more of these cavities and increase your Q factor. And if you read up the quantized inertia stuff, right? I like what Mike McCulloch calls it, you know, this Q factor. Where's the the high Q asymmetries, you know? So getting this Q factor and in these resonators seems to be the key. And the Q factor, I got to find a way to where he gives the the way to calculate that. But I'll send that to you. And I'll post that in the links to the chat afterwards. But that's more of a private technical discussion on it. But the Q factor can be multiplied by having these layered cavities, you know, by putting more layers, because you increase that potential of the cavity. So I think that that's how that they do it. They're creating this.
Now, is this going in lines with like the Casimir effect?
Yeah, it is very similar. It's a polarization of the vacuum energy and a damping of the Unruh radiation around it, right? So Casimir effect. It's essentially.
So Casimir effect is interesting because it polarizes the vacuum by introducing a material with a certain geometry. And in the classical experiment, the geometry of the material used is the fact that light has a different velocity through the space between atoms of a solid material, especially a conductor where electrons are free to transport because they are the easiest momentum carriers to interact with, and they increase those numbers of interactions between the tiny little electric waves that are traveling throughout the universe, these electromagnetic fields and electric fields that are hitting the plates and some of them being rejected. It's because the space in all of those atoms that exist in making those plates up reject some of those fields out and can reflect them back, because the electrons act like little springs for some of these radio waves, and they can push them back. So it's an interesting phenomenon. But yeah, the Casimir effect uses the fact that physical material has a different light velocity through it than light travels in open space or in free space. And there's also other technologies to simulate the existence of material in a given space and do some of the same types of things, which is where it gets really interesting.
Here's what I was thinking maybe would be good, right? So this domain of science, dude, you know this Dominic Wallace guy is? I was talking about you. I was talking about you with you earlier, right? This sorry, I'm tripping over my words. I'm so physically exhausted from moving and doing all this work. I wasn't even prepared for this. But anyways, domain of science. This guy, Dr. Dominic Walleman. Sorry, not Wallace. Walleman. Dominic Walleman. He has gone through this process of organizing the information. So he created the database, and then he organized it, right? And it's brilliant. This is like awesome. This is like, when I saw this the other day, I was like, this is exactly what I want to do with Hover Brothers. We want to create the map of all the classified programs, all the classified materials and shit, and then like show where all the gaps are. You know what I mean? So this is like shows all the gaps in quantum physics. These videos are amazing. People need to go to this YouTube channel after this and subscribe to this, ring the bell. Domain of science. These guys are freaking incredible.
Yeah, I haven't even checked them out all that much yet. I've heard of them, and I've seen a few videos, but I haven't really gone through some of their materials, and it looks like they post pretty frequently.
They're doing great to map everything out. So they created a map of mathematics, they got a map of physics, map of computer science. This is exactly what we need to do with is create a map through all this stuff, because this is a lot of cool stuff. It's going to lead to new technology. This is all the fringe, and yeah, we map that out. We're going to be good.
Mm-hmm.
All right.
There's a lot of associations that we've got to draw lines between here.
Oh yeah, we need, like, I don't know. I contacted Eric Weinstein too with the Portal project. The Portal. Are you familiar with this?
No, I don't know about the Portal project.
So go to ericweinstein.org, the Portal, and he talks about this geometric unity theory that he's got. Quite fascinating. He's done some amazing work with, you know, the polyhedral combinatorics and just mapping out all of polyhedra and connected space and connectedness is very cool, very key core mathematical stuff, which has very strong relations to how quantum physics works at the fundamental level through just pure mathematics and geometry.
I like the quality graphics that I'm seeing.
Yeah. This is his Portal presentation on geometric unity. He talks about the whole theory and breaks it down. He's a real smart guy. I think he's local around here too. I believe this was at MIT, but I got to get a hold of these people.
Yeah, man, we've had pretty good luck so far tracking folks down and being able to speak with them. It seems like a lot of these big names aren't quite as afraid to talk to you as people would believe.
Right. Well, I'm trying to make a name for myself too with the information I've connected people with already, because I'm kind of bridging the theoretics. There's a lot of theoretical people like this, and then there's the experimenters like you and everyone else in those groups. So I've really been hard on the experimental physics side of this, in addition to the theoretical side.
Well, that's because you understand the importance of getting it out there, and the way to do that is to show it.
Yes.
Show that it works. You can't
talk
about it all day because nobody cares.
It's the only way to do it. Well, people
Absolutely.
do care, and we're getting the people that care together to talk about it
Well, that's
and
because
figure
we're
it
doing
out.
demonstrations and we're being relevant. I mean, that stuff is important. That's why they care.
Exactly. Yeah, so this is awesome. And oh yeah, the Steinmetz solids, that was something else that someone had talked about. And that other one, man.
Yeah, still, this video will only get like 3,000 views.
Yeah, I know. It's not mainstream, dude. This is
Not yet.
not yet. This will be. This needs to be like taught to everybody. You know, it needs to be held in mainstream. I don't know. We need to get more people interested in this.
Then you got to think about, though, could you teach this to a fifth grader? Is this
If we
stuff
could,
simplified enough, refined enough?
if we refined it, maybe, but
That's what I'm
not.
saying. It still needs work.
It needs a lot of work.
It's something we have to be looking at, but it's not ready for general consumption, and it's on a package deal, and you've got all these little pieces are
So,
sort of like just ordering parts. There's no kit yet that you can just simply put
well,
together
the
and
thing is that
have.
everyone wants this fifth grade understanding of things. They want this packaged fifth grade, level of learning, and you have to
Well,
understand that.
can't blame them, man. Richard Feynman pretty much said it best, man. If you can't explain it to a child, then you don't understand it, and he's right.
Really, yeah, it's true. But at the same time, I think some of the stuff, like, yeah, this is a big course with a lot of stuff to cover. There's a lot of material to know. That you like. I like Heisenberg's quote where Werner Heisenberg said that it's only when you learn, like, he learned a ton that then he realized how little he knew. I forget the exact quote, but that's basically what he's saying. It's like only when he learned, like, when he got his PhD, he basically realized how little he knew rather than how much he knew.
Yeah, that goes back a long, long way. That type of quote. Was it Plato that had something on those lines?
Yeah, it's the fact that you can go so infinitely deep on this. That's the nature of the mathematics. That what mathematics is. That's why we created mathematics. It's the only tool we have to understand the infinity, and the depth of infinities. You know what I mean?
It's a hell of a concept to try to wrap up, isn't it?
Yeah.
Good luck explaining that to a fifth
But
grader.
yeah, it's a lifelong journey, and you'll never learn. It's like I really feel it's we all live our path and try to take on as much as we can, and as much as we're capable of, and as individuals, because some of this stuff, this Wolfram stuff, is like it's mind-boggling, it's mind-numbing, and it's mind-numbing
Yeah.
to not just me, to a lot of other people who see him. He's frustrated. He's banging his head against the wall now. This is where
By
they're
the way,
at.
it was Aristotle who said, "The more you know, the more you know you don't know."
Right. And that's, oh my, but it's also that
But yeah,
this
many
is where they're
many
at.
great scientists in modern names have come to realize this truth, and it's a continuous realization. It seems like the more the research humbles you, there's really no bottom to that, and yet that humbling is not a painful process if you're willing to accept the fact that we're really just sort of dabbling in the dark here, and we're doing the best that we can, and we have things that we've seen that do work and that we know work, and there are a great many more that we have no idea about. Some things do work and we don't have any idea why or how, but it's still satisfying just because that mystery releases dopamine in the human brain, and that is a motivator to get us to do things. It's that prospect of reward, a personal reward, not financial necessarily, but just the reward of discovery, of getting that thing that you were after, I think is what really keeps us on track and echoes through history for many of these minds, and it continues to this day.
Right. What did I have here? Anything I closed that I wanted to include? No. I'm just trying to clear out all my windows. Oh, this was awesome. If you go to EFPL, right? These search engines. This is a great. I gotta put this on the thing. So yeah, this search engine I found. I met this guy who's like a kind of a hacker dude, and he's just like, "What kind of stuff are you looking for? You're looking for more information on these scientific terms because I can only find so much on certain stuff." and a lot of the papers are outside the realm. And he's like, oh, search for it on these 3 websites, and science.gov was the other one. I went to science.gov, right? So there are some people in the government that are doing good things. You know what I mean? They're not. It's not. The government isn't all bad. It's not all just one agency. There's a deep state that is just works for the rich people who've always controlled everything and kind of have this stranglehold on everything. The billionaires, you know, and it's the Sacha Baron Cohen article we're talking about. But not everyone who works for the government, you know, and everything the government does is evil and bad, man. You know. So I
Well,
did.
that's because people like to personify this idea of a government, and it's not, even the term "the government" pretty much tells you everything you need to know about this idea that it's a generalization. It's not the government. There is no the government. It's just a bunch of people doing what they've been told to do for trade of wages, and it comes down to that. So the big separation between these very, very dark projects and the rest of the world pretty much guarantees that most people will be genuinely uninformed and wholeheartedly ignorant, not in the offensive, you're ignorant and stupid sense, but in the genuine definitional sense that ignorant simply means you do not know that you do not know.
Right. Well, so that's the best way to keep information is people don't know what to look up, and they're so busy looking up and arguing over all the fake stuff like Bob Lazar and the stuff that's in the New York Times and on the History Channel. You know what I mean? That with right up there with ancient aliens. You know what I mean? And that's the biggest hurdle and the biggest issue to getting true disclosure and true information out there is that information gap. But I guess, anyways, I went. Remember, I was talking about squeezed coherent states, and I've been saying all this stuff
Yeah.
about those, right? I went on the science.gov and I typed in squeezed coherent, and I got 71 sources, and the top 3 are from the NASA Astrophysics Data Systems research that they did, and it's on. It's very interesting that NASA's doing. Well, like I said, they're used also in the gravitational wave detection and all this other stuff. So there's a lot of other uses for them that NASA's interested in. But I just thought it was very interesting, all the stuff that I found on NASA doing quite a bit of research, and a lot of these are all Chinese researchers. So
this whole concept of squeezed light is a term that we bounced around a lot in many of these conversations, and it's got a lot of baggage of it, but I can't emphasize enough the importance of just those 2 words, squeezed light. Think about what that means. You have light traveling in a direction. It has a velocity because it has a directional vector. It has an equivalent mass energy because it contains energy. And effectively, it's the transfer of momentum from a charged particle produced by a charged particle at its point of production, now traveling through space and just waiting to interact with another charged particle so that it can either be absorbed, reflected, or interact in some way, or maybe just simply pass through and not interact at all. Either way, if you can take that charged, that moving electric and magnetic field, and you can compress them together, the only way that you can realistically do that is to compress space. So by recognizing that a compressed electric or magnetic field as a result of externally applied electric or magnetic fields whose wavelength changes is effectively the same thing as changing space-time, because space-time is an electromagnetic phenomena at its root, you could say, then we can begin to look into this stuff. So squeezed light has a very wide scoping set of research, and I can't overstate the importance of understanding what it is to squeeze light. Now with so many experiments that have proven it, that have fundamentally demonstrated that you can in fact squeeze light, changing the wavelength of a laser, for example, which is a coherent state of light.
Yep, and that's making tunable lasers, but also these polariton creating cavities that have new types of lasers. They create coherent photons in a totally new revolutionary way, which also could potentially produce negative mass. So it generates negative mass in the experiments. It's not negative mass. It's a weird thing. There's a lot to it. Here, let's look up negative mass on Wikipedia, and you can get a whole bunch of just introductory stuff to the whole phenomenon. Well, there's the wife calling. Time for me to get going soon. I'll bring all the plants and the fish over, but yeah,
At least you're out of that place.
Yep, at least we're out of there. And if I'm looking for, I don't know, I'm still trying on the hunt for like someone local who's really good at video editing and production and stuff that can help me set up the studio, because I have all the equipment, I have all this stuff. A lot of people have donated equipment and old stuff. If you know anyone who wants to help in any way, get a hold of me, thealienscientist@gmail.com.
As you're walking around in your local area doing jobs and talking to customers, just mention what you're working on. Say you're looking for a video editor to help you with your YouTube channel or whatever. And I have a feeling you'll find somebody very quickly.
Yeah.
Just set your mind to work on asking that question and making sure that you screen it past every single person that you meet. And inevitably, by statistics alone, you'll find somebody who's skilled that wants to do it and will be interested. Then it's just up to you to explain to them the ideas that you have well enough where they get captivated by it and want to help.
So lots of cool theories on gravity going, lots of cool experiments going, man. Anything else you want to throw in before I gotta get off here shortly?
Nope, as of now, I'd say we're pretty good to go.
Yeah,
so,
yeah.
Let's take what we've got in stride and continue the research.
I don't want to
get back on this topic another day.
Right, I gotta get back to the lab and get back to life. I didn't want to make it longer than an hour because people get overwhelmed, and it's. Oh
yeah, well, it's kind of a impromptu. Let's just do a broadcast.
So yeah, dude, it's so awesome that so many people turned out. We had a huge turnout, a great chat going, and
it's not bad. I think we shared some good information on this one too, and also the demonstrations I think are really helpful. I'd really like to focus more on demonstrations, and I'm working on getting that new YouTube channel up where we cover that and we cover some of the history of this research, because really, like, if you look far enough or deep enough into it, none of it's truly original. People were futzing around with the stuff a long time ago. The only problem is that the terms they use to describe the phenomena are all completely different, but the same thing is happening. You just have to get through the language barriers of definition and cymatics.
Yeah, so I apologize again to the member of the audience that because I called them a liar, and I don't know if they were a liar or not. It just seemed kind of implausible, but I never know with the people that I meet on these streams. It seemed to attract a very unique and specialized, type of individual. So it could have been someone that actually knew Gene Malov and was there that, and everything.
I don't know about that, Jamie. I was there for that, watching that one, and I just really didn't get any kind of whatever that person was there for. It wasn't really to help. It was to create controversy, and everything that was said was controversial. Man, if people could see some of the comments that we didn't allow to be seen, some of the banned comments, and just how racist they were, how inflammatory they were, it was ridiculous. This person was clearly not interested in helping anybody.
Right. Well, that's unfortunate. Yeah. So I don't know, but I did overreact because I just got upset with all the racist and terrible things that people were saying, and I don't know. It's just it gets to me sometimes. Some of these people on there, that just like all they do is just try to troll, and it's like you don't contribute anything. It's like if it'd be one thing if you're like talking shit and then you're actually coming and delivering something and serving it up, but like it's just these people that are just. They talk shit and they just get you all riled up, and then they go and call the police when you hit them, instead of showing you a real fight.
I don't know, man. I really I don't really get riled up by these folks.
I don't get either. I don't want to hit anybody,
and they have a lot to instigate, but really that's the whole game, isn't it? It's sort of you and your psychology against something that's fundamentally opposed to what you stand for. And if you can handle that, and you can take your Zen moment and realize what's going on, that somebody's trying to fuck with you and you're in an intellectual battle, not a metaphorical or moral battle, then it's not too hard to turn the tables in your favor.
Right, and that's why I like the pre-scripted approach, because you don't get that emotional and that sidetrack thing. But I also like the live updates because it gives them more personal and right there connected.
I'd recommend that people study the psychology of MK Ultra tactics, and I know that's a bit of a term here that probably just got this show shadow banned, but look that up and understand how it works. Understand how breaking a personality works and why it works and how sadistic it is, and then understand that there are circumstances in everybody's life where this happens to a smaller degree, and many times it's not intentional, but people have events in their life that shape them permanently, and many of these happen in our childhood. So this is what creates those types of psychologies. And now you'll find that people are susceptible to simple ideas that seem illogical at first but have a very strong emotional content. We have to get around that stuff that creates scientific biases. And it dissuades us from actually looking objectively instead of subjectively at what we're researching.
Right. So, all right, man. Yeah. Anything else? So yeah, here's all Jack's papers and stuff too. I got some point. I have a folder on Jack Sarfati. I contacted him about getting all of his stuff. Another theoretician, and he sent me to this, and this is all his papers. So I still need to go on here and download all of these and then upload them to that folder. Either that or we'll just put a link to this page on here because he seems to have it, but I'd like to keep a backup of everything because stuff tends to disappear, or.
The idea is that anything that's not copywritten, anything that's not claimed as intellectual property exclusively, right, that we can get on there because we don't want to share.
The public database is going to be different than the private database.
Very much so, but yeah, we definitely. Everything I'm sort of focusing on to how are we going to get that all public and how are we going to show what's able to be shown only public stuff and make sure that we separate it. So it's quite the task, and that's one of the things for people that are wondering, like, when is this going to come out? When can I download it? I want it really bad. That's what we're sorting through. There's so much information, and new information is being added at the same time as we're going through what we already have in there. So it does take a lot of time, and we're still going to be working on it for a long time yet. But when it's ready, it will be organized in a way that will make it useful. And even if you had access to it today, for those who are trying to gain their hands on it, it's not going to really be all that helpful because it's just a bunch of files. And things are in folders at this point, but they're still not organized in the way that's going to be extremely useful to researchers. So,
no.
We have it ready.
It needs to be cross-referenced. There needs to be all kinds of metadata and everything else done to make the whole thing workable and searchable in a method that's appropriate.
So there's no reason to release a useless database. It's got to be finished, and it'll get there.
Right. It will get there, but and I'm using this guy, Domain of Science, is again one of my inspirations. These maps, creating these maps, and giving these overviews and everything. Like this is what I was saying about the information. This is a course on quantum optics, and it gives you everything you need to learn, all the textbooks and everything. This is good stuff for people that want to teach themselves, and it's important. Sometimes knowledge isn't easy to get. You have to work towards it, and you have to want it. It's rewarding once you have it, though.
Absolutely, it's rewarding, and it is extremely hard to acquire.
Yeah, it takes a lot of hard work, man. Especially the math stuff, because maths are not they're not fun. Not usually, generally fun.
Well, the maths are your job, Jeremy. The experiments, I'll take care of.
All right, man. Yeah, I'm not. I got some mathematicians and theoreticians that are beyond me that I try to work with. There has to be an overlap to get to the experimental world because you can't just be complete theory. It has to be well, how do we test this? How do we, That's kind of the line.
Yeah, something's got to be provable at some point. Otherwise, it's just a useless theory.
Yeah.
Has string theory still yet produced any predictions of any usefulness?
Last I heard, Leonard Susskind is pretty much he's been he talked about Wolfram's physics project and Eric Weinstein's geometric unity thing, and He's like, this is, where it needs to go, basically. So admitting it, this is where physics needs to go. I don't know what his words exactly. I don't want to put words in his mouth, but there's an interview with him recently where he was asked about this. It's quite revolutionary, like a very quiet, subtle revolution, and
Interesting. Yeah, that I haven't seen. I haven't seen that interview. But
yeah.
Hey, maybe link that in the end of the chat. Right
Let's
before you get
find it
off.
real quick. I was on Lex Friedman, yeah. This is the one. I don't know exactly where it was, but it's an hour long. But it's in there. I'm almost positive it's in there. Yeah,
well, it's good content to watch anyways.
This is the one. This is the one. This is the one. It's really awesome. Good content. This guy's a genius. He is absolutely. If you don't know who Leonard Susskind is, get on it. Because he'll tell you more about string theory than most anyone.
Yeah, this will be interesting. I haven't done my due diligence to really have that strong of opinion on string theory, other than what I've heard about it from fellow researchers and the various things that I looked into years ago, which I mentioned are probably fairly out of date at this point. We'll see. We'll take a look into it.
Yeah, no, it's all theories that try to resolve this. Okay, quantum non-locality.
Yeah, that's the one big thing that I have yet to see from quantum physics or really any other area other than electrodynamics. Is what does allow the speed of light, what causes it in the quantum view. I have a very good understanding of that mechanically in the electrodynamics view, which makes total sense and fills in those variables, but in terms of the quantum view, that I don't have yet, and I have yet to see the explanation of some of these non-local effects as far as the carrier of the action. What is the mechanism of interaction between these particles at a distance? That's just something that I have not yet seen well explained.
Nope. And quantum non-locality it tells you how to break Einstein. This is what people need to learn to really to get there. But again, this is the theoretical stuff.